So following on from the previous two videos, we got to this stage here where we've established that the gradient is always negative. So it's always going downhill here. It's always going downhill, and this here is always going downhill here. Okay, so now we need to detect if there's any points of inflection here. So we need to find the second derivative of this. So the first derivative being this. Now we need to consider the second derivative. So we've got to differentiate. We've got to differentiate this, but rewrite this as a product. Well, you can use the quotient rule. It's up to you. So for me, I'm going to write it as a product of two things. So now I can just use the product rule here. So you've got one thing multiplying another thing. So our task here is to differentiate this. Remember, hang on. When you try and differentiate this, it becomes this. Now, when you differentiate this here, when you try and differentiate this, you can imagine this as being a one. Don't forget u here. So is a function of x. So when you differentiate this, you can imagine this as being a 1. The 1 gets moved down to here, so that will give you minus 1 times, 1 times minus 4 will give you minus 4, and then you've got e to the power of u. Okay, how? So when you differentiate this here, it will give you this, but because u is a function of x, you've got to use a chain rule here. Okay, so so now we've got to differentiate this here. So we're going to use the product rule. So the product rule is to differentiate this, leave this the same, and then later on leave this the same, and then differentiate this. But the thing is, when you differentiate this, it's quite difficult. So hang on. So when you try and differentiate this, it will become this. Hang on. It will become this, and then you've got to times du by. So imagine this as being like a u here. So here let u equals 4 over x. So remember, when you come to work out du by dx here, it will well, it's up to you, but when you differentiate this, it will give you this. Well, anyway, use whichever method you want. If you differentiate this, so now we're going to differentiate this. So use the product rule. So differentiate this. That will then give you this whole thing here. Okay. Well, hang on. Let me go back one step. We are trying to differentiate this. This at the moment is this times this. Remember, the product rule is differentiate this, leave this the same. Okay, that's the first part of the product rule. So when you differentiate, so our first part is to differentiate this, leave this the same. So hang on. So when you differentiate this, and then leave this the same. So that's us. So hang on. So this, remember, the first part is differentiate this, leave this the same. So that's been, so differentiate, leave this the same. So that's done. That's the first part of the product rule. Okay. So it's me leaving this the same here, and when you differentiate it, sorry about this. So here we're trying to differentiate this. So the first part is differentiate this, leave this the same. Okay. So differentiate, leave this the same. So that's the first part done. And then the second part is to leave this the same, and then differentiate this. Okay, so leave that the same, and then differentiate this. Remember, when you differentiate this, it will be negative 2 to the power minus 3. So negative 2 to the power of minus 3. Okay, so anyway, use whichever method you want. If you differentiate this thing here, it will give you this. Okay, and then tidy it up, and then it will give you this, and then tidy up, it will give you this. Okay, so overall, oh yeah, looking at this is in common, this is in common. You can factorize, you can factor it. Okay, so overall, f double prime equals this. Okay, so now try and find out if there's any points of inflection. So we need to set this to be 0. So find out when this thing here, find out when the second derivative will be 0. So that's you doing this. Set this to be 0 here. and then try and find out when it would be 0. So it's blah blah blah. So looking at this here, so so find out when f double prime is 0. So times both sides by x to the power 4. That will then give you this. Now, looking at this here, so you've got this thing multiplying with this thing. You've got to, when does this whole thing here be 0? You see, if you set this to be 0, then the whole thing will be 0. So it really boils down to you it's you trying to set this thing here to 0. So when will this be 0? When x equals minus 2. So we've got a point of inflection at x equals 2. So we know there's an inflection point somewhere at x equals minus 2. So now put minus 2 into the original function here, then that will give us the inflection. That will then give us put this into here, and then that will give you this point here. Hang on, blah blah blah, blah blah blah. So f of minus 2 will be this, meaning that our point of inflection, the point of inflection right here will be minus 2, comma e to the power of minus 2. Okay, so well we know that when x equals 2, if you put x equals minus 2 into here, then the y value will be right here. Okay, so we know this is our point of inflection right here. Okay, so what that means is that so now we know that this point here, we now need to consider the interval. So I will cover that in the next video. Okay, so this is what we know. There's a point of inflection right here. Okay.